Alright, so like I said, we're going to look at one last part today. So we are looking at solving with complex numbers and then finding values that make them true. So if you think back to our last unit or our last section, we were solving quadratic equations by factoring or by solving for x squared and taking the square root of both sides. So that's kind of what we're going to do again for all of these. So when it comes to solving with quadratics in complex number notation, our goal is to solve for x squared. So our goal is to solve for x squared. Once we have solved for x squared, then we are going to take the square root of both sides. And that gives us our final answer. So in number 1, I have 9x squared plus 54 equals 0. So to solve for x squared, I'm going to subtract 54 to the other side. That gives me 9x squared equals negative 54. I want to get x squared alone, so I'm going to divide both sides by 9. And I get x squared equals negative 6. Now, in the past, you would have looked at that and said no solution, because we had learned that you can't take the square root of a negative. Now that we know complex numbers and have an understanding, when you take the square root of both sides, you get rid of the squared on the x, so you get x equals plus or minus the square root of negative 6. But now, we know that anytime I have a negative under my square root, I bring it out as an I. So I get x equals plus or minus, because a squared has two answers, I square roots of 6. So same idea, same concept, same steps in number 2. Solve for x squared. So in order to do that, we're going to divide or subtract negative 48. Then we're going to divide by 3. And I get x squared equals negative 16. 16 is a perfect square, but it has the negative, so you get x equals plus or minus the square root of negative 16. So again, we think of that as like the square root of negative 1, which is I, and the square root of 16, which is 4. So we get x equals plus or minus 4i. In number 3, once again, solve or isolate your x squared by adding and dividing. So you end up with x squared equals negative 30. Taking that square root, you get x equals plus or minus the square root of negative 30. So 30 is 3 and 10, so no perfect squares. 5 and 6, no perfect squares. 2 and 15, so 30 does not simplify inside, but we bring the negative outside as an I. X equals plus or minus I square roots of 30. You must have the plus or minus in order to be correct. Solving for x squared in number 4, you get 8x squared equals negative 2. Divide that by 8, and I get x squared equals negative 2/8 is the same as negative 1/4. 1 and 4 are both perfect squares again. So when I take my square root, I get x equals plus or minus the square root of negative 1/4. But that's kind of like the same as plus or minus the square root of 1 over the square root of 4. So 1 and 4 again are perfect squares. So x is equal to plus or minus I, and then 1/2. And again, the order, because that was some of the questions I got asked, the order you put the 1/2 in the I doesn't necessarily matter because multiplication is commutative. So some of us write the I in front of the number, some of us write the number in the I. I will 99% of the time write the number and then the I, just because it's like logical to me, but it's not wrong either way. So if you left your answer as plus or minus I times 1/2, that's still the same thing. So these ones are a little bit different. So we have 3x, which is considered a real number, negative 5, which is considered a real number, because it doesn't have an I being multiplied by it, as well as 7 being a real number. So what we need to do in these problems is identify the reals and then identify the imaginaries. So 3x minus 5 and 7 have no i's, so they're considered real. Y minus 3 is multiplied by I, and 6 is multiplied by I, so they're considered imaginary. So what we're going to do is set the reals equal to the reals. So 3x minus 5 is going to be equal to 7. And then you're going to set the imaginary equal to the imaginary. That's going to allow me to solve for x and y. So every time you have the imaginaries, you'll be able to divide away the i's. So you end up with y minus 3 equals 6. And then you're going to solve for y. So you're going to add 3 to both sides. And we get y equals 9. Then we're going to also solve for x. So we're going to add 5 and divide by 3. And we get x equals 4. So the values of x and y that would make that true are 4 and 9. Don't have to do anything with them. So once again, you want to look at the problem, identify the reals. So what does not have an I being multiplied by it? And then identify what does have an I being multiplied by it. And set the real stuff equal and the imaginary stuff equal. So 20 is going to be equal to 5x. And negative 12 is going to be equal to 4y. The sign with the 12 comes with you into your problem. So I get x equals 4 and y equals negative 3. Okay, your homework is on the back. You won't be able to fit, all of those problems up at the top. Maybe you can do like 18 or 25, but after that you're going to have to drop down. And then my other hint is for 46 and 47, you need a system of equations, which is what we did in chapter 3. So 46 and 47, give yourself the hint, elimination or substitution.